understand the real-time analogy. Okay, so we all have been to schools, right, before. So let us say that whenever the students are going to school, they usually they carry lunch along with them, isn't it? So each and every school they have a dedicated time for lunch, for for lunch break, and the student they take their lunch. And at the same time, students, most of the students, they will not make sure that the garbage will be disposed after having the lunch. For example, there are chances that the food will be spilled over. Right? There are chances that they develop a lot of wastages. There are chances that they throw a lot of food on the floor. Right? For example, let us say that there is a school here. Let us say that we have a school here. School A has its own set of rules. The first rule says, whenever you are carrying your food, when after completing your lunch, please make sure that you clean your benches. Or please make sure that you clean your clean the food that is spilled over. Secondly, it also says, please make sure that you clean your places before leaving the class. You clean the you collect all the garbage and make sure you collect all the garbage before leaving the class. So these are the one set of rules and regulations for a typical school. Name of the school is A. So they have these two rules. Make sure that you clean the food that is spilled over, and while before leaving the class, make sure that you collect all the garbage before leaving the class. Okay. So there is another school. There is another school by the name of School B. So this is just an analogy. We will understand it better. These things really, it will not make any sense if you compare this with Java. But still, this example, I think this example could be considered. School B says, School B has one set of rules. What School B says, they do not have any rules over the garbage, even though they do not want to make sure. You can eat and leave the place. The premises will be cleaned. You can leave the class no matter how much the garbage is generated. So this is a real-time analogy. If you look at this, right? In the first case, in the school A, they want the students to make sure that the places are cleaned after eating food or whatever it is. The school B, this is the case in the school B, right? So if you apply these concepts with, if you just try to differentiate the same concept with programming languages, school A is nothing but C++. School B is nothing but Java. What does it mean? C++, the developer is responsible to create an object as well as he is responsible to destroy object. Object in the sense, again I am repeating, object is nothing but memory allocation. Developer has to make sure that the memory is getting allocated for the properties after using it. As soon as he uses those memory, as soon as the program is utilizing those memory blocks, the developer needs to make sure that those memory is getting deallocated so that the next person or next application that is going to use the system will not have any memory issues, right? But in Java says you create object, but don't worry about object destruction, we will take care of that. right? Memory deallocation will be destroyed by Java itself. Developer doesn't have to take care of it. Hope you're able to understand. Okay, sir. This different. I mean, this analogy is making some sense. What difference that is actually make when the like when Java is destroying object by itself? What difference it is going to make for the developer? If you go back to the previous example, whenever like we have developed a class called student, right? We have two properties. We had two properties in our previous class, right? Every time you are executing this program, these two properties are consuming 10 bytes of memory, right? Just imagine that if Java is not destroying these objects, and at the same time, just imagine that if you as a developer has not written any logic to destroy this object, you as a developer has not written any logic to destroy this object. At the same time, Java is also not destroying the object. So when you are executing this code for the first time, 10 bytes of memory is consumed. It is locked. The space is consumed. You may be having 1 GB of RAM in your system. So in the 10 bytes of memory is consumed. 10 bytes is nothing, a small memory block. But if you repeat this code, if you repeat this execution for what, 1000 times, right? 1000 times into 10 bytes. So this much of memory will be blocked. And if you increase the repetition, if you keep increasing the repetition, this 1 GB of memory will be exhausted. So you will get out of memory error. So it is very imperative to make sure that objects are getting destroyed or memory is getting reallocated as soon as the application gets the execution completed. Hope you're able to understand. So what Java says, you create the object, but Java takes care of object destruction. Object destruction. Now we will understand this in simple example. Now it will make more sense. So this is the simple analogy, and you can just keep this in the mind. You do not have to keep notes for this. It's a simple analogy. Okay. So let me write a small Java program. So let us take the same previous program itself. So this is the syntax, isn't it? This is the syntax. This is the main method, and we all know we need to imagine. I mean, as a beginner, we have to think like a beginner. How the beginner thinks. Save the code with .java extension. Perform the compilation. Send the compiled file to JVM. The JVM is going to create what? Main thread. And the main thread will try to get access to what? Main method. This is how a beginner should think every time. Every time. Even though if you are writing a complex logic, this is how you have to think. The first thing is student.java. Student.java will be compiled, and student.class file will be generated. Will be sent to you what? JVM. JVM is going to create what? Main thread. The main thread will try to get access to the main method. First instruction. The first instruction clearly says it is using a new keyword. The new keyword means allocate a memory. Right? What is identity for the new keyword? Object 1. So give that identity. So this object is going to save the two properties, which are nothing but these are the two properties that we have given. One is name and the second one is name equal to ABC, class equal to 10. So JVM has completed executing this instruction. So again it will encounter the second instruction. So this instruction says object1 dot name. Object1 again is a identity, right? Object1 is identity. So this is object1. I forgot to mention one. Object1 is identity. Dot means dot operator name. Get access to the name. This is the name. Right? Object dot name means it is talking about this, and it will get access to the value. So in this case, output will be ABC. ABC will be printed. So in the next instruction, object1 dot class. Again, object1 dot class. The value inside the class is 10 and 10 will be printed. Okay. After printing all this, the main thread will encounter the closing parenthesis. I mean, it will come out of the main method. As soon as it comes out of the main method, the JVM, this is the JVM. 1 minute. This is a main thread. Main thread will be destroyed. Before even destroying the main thread, the memory block that was allocated will be destroyed by the JVM itself. This is why destructors are not required in Java. Destructions are nothing but memory deallocation. If you take C++ programming language, we have to write a code for this. In order to destroy this object, we have to write a separate code. Like we have written a code, right, for the object creation. Likewise, for the memory deallocation, we have to write a separate code like dealloc. C programming language. Sometimes what happens, C++ developers, they usually forget to do these things, but it will show a huge impact in the real-time applications. For Java, it is not required because Java itself is taking care of all this. That's why Java has become the simple programming language because of this, because they have eliminated this complex task that has to be taken care by the developer. Right? I hope this is making little sense. Not sure. Just type S in the chat box if you have understood. If you need any repetition, you can again type S in the chat box. Samyukta, what about you? Are you facing any issues? You can both can unmute and talk. If you want me to repeat, I will repeat it once again. If not, we will discuss a little more theory about this.
It's clear, sir.
Okay. So let me I can tell you a little bit theory for the better understanding. So in Java, okay, let me save this before proceeding. Okay, here I can write. So in the layman terms, we can say destructors. But if you have to open this up in the interview room, your definition should be perfect, right? So how we can create a perfect definition? You can simply say why destructors are not allowed in Java. You can simply say in Java the garbage collector. So garbage collector is not the actual garbage collector that we come across every day. This is an internal topic on Java. Garbage collector is nothing but the deallocation of memory. In the real time, in the real world, garbage collection is something what? Disposing the garbage, right? Dumping the garbage in the bins. But in Java, garbage collector is nothing but deleting the unused memory. So the garbage collector automatically deletes the unused objects or the objects that are executed completely to free up the memory. We as a developers do not have to worry about the memory deallocation. The Java itself will take care of the memory deallocation. This is why the concept of destructors are not there in. Just try to please understand, this is one of the popular interview questions. Definitely there are high chances that you get this question, because they test your knowledge, they test your understanding in Java in comparison with other programming languages. So this is like you are dealing with two programming languages here. You say you know Java, you must also know why the destructors are not allowed in Java, but why it is allowed in C++. No, you should aware these two things. You should aware the Java programming language in comparison with other programming languages. This is how a question can be asked. If anyone is asking you why destructors are not allowed in Java, this is a simple answer that you can give. Java, the garbage collector automatically deletes unused objects, or we as a developer don't have to worry about the memory deallocation. The Java itself will take care of the memory deallocation. And at the same time, in C++, the situation will be like this. Developers, they keep creating the objects in the sense they keep adding the memory blocks. At one point of time, they forget to deallocate the memory. If you keep executing the program over and over again, right, there are high chances that the memory gets exhausted. So the system will behave normally, and there are high chances that the execution will not be proper. Right? That is a big burden for the developers when you use C++ programming language. That is a responsibility. It's not a burden, it's a responsibility. Developers should be more responsible to make sure that the created objects memory that was allocated should also be deallocated as soon as the program completes its execution. In Java, it is not the case. The developers do not have to worry about it because internally JVM is taking care of it. Simple explanation. Right? I will share you this recording to you.